Hello everyone, this is Blender Guppy. In this video, I'm going to use random flow to model a simple space station for your background renders. So first off, we're going to just model the base mesh, then detail the base mesh using random flow. So I'm going to start with a cylinder, and so you can actually use your own design for the base mesh. I'm just going to use this template. Inset, and then with this face selected, Control E and bridge those edge loops. Okay, in the Y, I'm going to go press 1 in the numpad to get me to the front view, and I'm going to delete these faces. Okay, selecting everything and then pressing F to close the holes. And by the way, in the add-ons in preferences by pressing F4 and then using clicking on preferences. I'm using OBS Studio, so if I click this, you can see the window. But clicking it, go to add-ons and then look for the F2 add-on and then the Loop Tools add-on. So F2 is basically just a uh, add-on for quickly creating faces based on your edge selection or vert selection. So you don't have to select these 4 vertices here just to create a face. You can just select this edge, press F and then F. And I also used that earlier to close the open faces here. So selecting everything, press F. And that process cannot work on something like this, okay? So F. So that actually needs an edge. So for that situation, it cannot work on that, but for something like this, it works. Okay. Selecting this middle vert here, I'm going to place I'm using Creative Flow and place a cube there. If you don't have Creative Flow for quick placement like that, you can select the edge, Shift S, and then cursor selected. So in Blender, the primitives or any other objects added using the Shift A will be added to the position of the 3D cursor. So Shift A and then cube. I'm going to scale that like this. I'm not going to use Boolean to merge it to this. I'm just going to join it in edit mode while not making it a unimesh. So let's just leave it at that, just to have less problems with the topology later on when we use random flow. So there's maybe we could add some more design here. Yeah, I'm going to add more topology just to make the result of random flow much better. So the random flow works better with evenly spaced quad faces. So the subdivision in random flow, the subdivision script, or the subdivision when using the random flow operators works only with quads and tries, so not in-gun. So you can see that in my videos, the base mesh are always quads unless not needed. So it's gonna make an edge here. Oops. Okay, so K for the knife, A to snap it to the angle, and then press C to cut through. Okay, same with this one, J to connect, select the 2 vertices and J to connect. Okay, and also this. So the look The same on the other side, so I'll just use K, A to snap to angle, and then C to cut through. Okay, now we have mostly quads. We can get rid of this, of course. There we go. Okay, just gonna save this. Okay, we have our base mesh. Now we need to, I'm going to mirror it. Uh, you can decide not to mirror it to make the details asymmetric, but for this instance, I'm going to symmetrize it. So auto mirror in the x-axis only, and also um, auto smooth. So this does not meet the sharpness right here. I want this edges to be sharp. So I can just probably decrease this until the no. No, it can't be done using the angle. So what I'm going to do is click on these edges and Control E, mark sharp. Okay. So next up, I'm going to save this base mesh using data save in random flow, because I'm going to use I'm going to use a destructive operator for this, not not a non-destructive random operator. I'm going to use plate and sets, which is a destructive method of detailing the object. So we save the data and we can reuse it again even if we mess up this mesh data here. We can just reuse the original. And the data you save using this feature is also saved when you quit and then open Blender again. As long as when you save using this feature, when you save the mesh data, you have to save Blender as well, Control S, so that data is also saved in that Blender file. So when you open it up, you can still use it, of course. Clear means that it's going to clear all the saved data. Okay. Wait a minute. Where's the mirror? Okay, because we use the data X and the data set. I think the data set using the data feature is actually this data without any modifiers. Okay. Yeah, we're going to use plate and sets. So this detail here will allow you to the detail I'm going for here will allow me to render this mid-range or far away, but of course you can still render it closer, but too close, depending on the texture you're using, or for the tertiary, whether it's geometry or texture, depending on the details that you are using for the tertiary detail. I mean the what is it, the resolution for the tertiary detail that you're using. Then you can use it for a more close-up render. Okay, selecting every faces. So every faces in the mesh. I'm going to go to utility, plate and sets, and we'll start with the basic. Okay. So increasing the subdivision increases the amount of faces in the mesh and increases the amount of faces you can play with, or the operator can play with. So you can see that the details or the inset or the extrusion is a bit too harsh or strong for this kind of object, which is supposed to be really big because it's a space station. So in the depth, this controls the depth of the inset or the extrusion. So let's set it down to 0.005. Okay, 0.01. Okay, 0.005. And the thickness is 0.005 as well. No, 0.008. Okay. So in this one, we're going to, what is this? Don't choose mirror. Okay. See the center line here. We can get rid of that using the clip center, or you can use the or toggle off the use mirror. So those lines can still generate at the center, but the possibility of it appearing is greatly reduced. Okay, so we're going to increase the number of plates. Plates refers to this boxes here, or rectangular details. So this is extruded out, this is extruded in. So these are the plates. And right now it is extruding, depending on the resolution, or it is insetting or extruding out details, plate inset details, and the amount of 500, uh, possibly, because it is relative to the resolution. So let's increase it to 1000, and let's us use fill. So fill means every space between the plates will be used, whereas the clear, sometimes some of the spacing between the plates will not be used. So this will have, in essence, this will have more rest areas depending on the plates number that you're using, and this will have more BC detail and with less rest areas. And instant mode property is a new property. If you don't have it yet, then this will be on the next update. Basically, non-even gets rid of the spikes when using the even mode and increasing the depth or the thickness. So you can get rid of the spikes using this one. But let's just use the default even. And let's try and make the detail smaller. So the size of the rectangles, you can see this is the one. And let us decrease this 0.005 and increase this to 2000. So I'm trying to view it on this distance. So I mean, try to view it at on the distance that you're planning to render it. Just so you optimize the subdivision or the amount of detail you're using. If it's too small and you can't really read the details too much on the distance that you're planning to render it, then just go ahead and use less subdivision and bigger faces if you want to make the details more macro in that specific distance. So actually, this could work for us now. It's good. You can of course random seed the result using this plating seed right here. You can see that in other operators, the seed value right here is positioned elsewhere, but in this one, it's here because the original code for this came from random starships. So I basically used that code and put it here and maintain the configuration of the property in the redo panel. Okay, yeah, let's use this. It's good. Okay, what I'm going to do now is try and break up the profile. Okay, start drawing. Oh, there we go. So the profile is this one here. Let's try and break that up. Of course, there's a bit of a breakage already using the inset, but it's too it's too subtle because the object is really big. It's supposed to be really big. Okay, let's select everything, and actually, okay, there's actually a way to select these faces without selecting this side faces here using face select, but this is a new operator, and it, okay, let's try this one. Oh, I'm supposed to select everything. There we go. Yeah, it's a way to select some of the faces, some of the top faces without selecting the margins. But this is a new operator slated for the next update. Okay, select everything, and let's try to what you may do to break the let's try slice. Okay, so slice basically is why okay, the 3D cursor keeps jumping off to other places. Okay, so not random slice, random cells. I mean, okay. Let's increase the subdivision. Increasing the subdivision makes the faces generated smaller based on the original topology that is selected. So that's the original result. This is we can offset this for the mesh, or we can create depth like that, and these are considered, each of the cells are considered face islands. You can increase the island size using this or using the pool size, but I have toggled this on. So when they meet each other, eventually they become a single island. But when they are separated, each separate island can be offsetted individually like that, or the cut method, the depth, yeah, without the offset. If I increase the island, each cell will be of course have a individual depth or offset, but be careful on switching to individual, especially on high resolution and when you're using large amount of pool size, because this can slow down Blender or probably crash it. So, but the offset mode for the individual is much safer, but of course, be careful. You can see here that this bunch here did not offsetted um, because offsetted in unison because they are not corrected. I mean connected. But if they were separate, you can see that they have different offset. Okay, let's switch back to original and let's use it here. So the result will be non-destructive. The result will be a separate mesh. Random cells. And let's try and since we already have this much of resolution, we can actually just experiment on the result using zero subdivision. And let us increase the depth to see what we got. Suppose size mode is using percentage. We're going to use a more strict or precise number using just number or integer. So 50. And the size, okay, let's try an offset mode in the individual so they don't have the same height. And we can also reduce their size by increasing the subdivision. Again, be careful with the subdivision. So that's one way of breaking up the profile. And again, make sure that the detail is in your render range. Make sure that most of the details will still be noticeable on the distance that you are trying to render it. Okay, let's. You can where's the seed? Pull seed. You can randomize the position of the random cells using this pull seed. Let's try and look for something that looks good. Okay, let's try 100. Um, and let's go to where is the depth? Okay, 0.05. There we go. Oh, not the depth. I think it's the offset. 0.1. No, 0. Full seed. 0.1. There we go. Okay, I think we have it. If you like most of the result, if you like most of the result and don't like some of the placement of the other detail, you can just go in and press L to select all of the faces in that particular first island, and then XF to delete. Same with this one. I don't like this one. Okay. And yeah, let's go with this one. So we can try other stuff. Um, like scatter. So scatter, let's just use cube, or you can use a particular mesh, or you can use a selection of meshes. So 0.01 here and 0.05 as a start, and let's slowly increase the number. It's slowing down. Okay, something like 200. Strict. So its alignment is basically depends on the face normal. I may probably add an option to not to make you select between the face normal when it is created, or just strictly XYZ and let you control the rotation later. Yeah. So we can randomize the scale. Oops. Yeah. And so the scale. So let's not randomize rotation, only the scale. And let's increase this to 300. Okay, just 200. There we go. We have, so what I did is just break up the interior or the inner space. And what I did here is break up the outer space. This is for breaking up the inner space and also this detail here. Okay, so we can actually just stick with this. If you want to populate this with spaceships, you can do something like with the 3D cursor here, I can add a UV sphere, and then random scatter. Set this to a higher value first. Okay, and when you have a collection of spaceships, so make sure that they're low poly to mid, because this can slow down if the mesh or the collection of meshes you're using are really high poly. So, but I don't have that kind of collection, so I'm just going to make the example using the cube, and then you can explode it. Uh, uh, no, using the sphere obeys the normal, so we'll just probably just I'll fix that in the upcoming update. So we'll just use the um the cube, random scatter, cube, and then explode. And you can see here that the explosion is not really circular, but we can adjust the margin to make it more chaotic and make it seem like the explosion is radial, even though the source mesh is a cube. There you go, and you can there. So imagine these are your spaceships here. Let's delete this, and then I think animate z-axis, so like that. So we don't want that because we can um lose parts. What am I trying to say? Separate them by loose parts, then create an active object. I'm going to assign them to a collection. Control G, just so I can easily select them later on. So Shift G, this is just for example. Shift G, random animation. Um, let's see if I remember this correctly. Z-axis. There you go. You can set by separating the scatter object. You have set um, individual individual animations for it. I can add parent, and then I can just drag these spaceships here. Okay, there you go, our spaceship. But that's for another tutorial. Whoops, whoops. Okay, Shift G and collection. Okay, okay. Next up, okay, our model is finished, and actually the only thing left is just to shade this or texture this. But first, I'm going to add a basic color for this using the random vertex color. And again, I'm using black and white right here. So so black and white, just set the saturation and min max to 0, and then value set it to 0.7 or zero point 0.9 for me. So the min is the darkest part. So right now it's in object. You can use island, but the unimesh, our main space station is unimesh, so we can't use object or island, but we can use sharp. It will individually uh, as assign a different vertex color on the mesh based on the sharpness of the edges. So mark sharp. There you go. And you can play around with the value settings. The value randomization of the vertex color using this one here. So H is V, H is U, S is saturation, and V is for value. Okay, so we have Umax here, RGB, and Umin. You can also use the color wheel here. So there's a lot of things you can do with it. Okay, I'm just going to append a shader that I used for from an earlier work. HDRI. We're going to use this and a Shift G T to select all the mesh type objects and then assign the grunge metal. Okay, let's try that. Try this. Okay. It didn't have vertex color. Let's use island, island. And the shader is actually, I think, using a UV. And these are not UV'd, but you can quickly create a UV for this using a cube projection. Since we're just going to render this mid-range or far away, so we don't need a truly specific uh, UV for this. So at this distance, you can see that our cube projection works well. But if you look closer, it fails right here on the slanted faces. You can also use Shift GT. You can also use Smart UV Project. But for this instance, I think cube projection works. And if the object is truly large, then you can use truly big. Then you can use light map. So what is essentially what light map means is that every face is a UV island. We can actually work with this. Let's try 10 scale. By the way, the texture I'm using for the detail is also derived using random flow. I basically just random flow a simple plane and then bake the result and then use it for details. So there's a video for that if you look in the playlist. Then we're going to add the lights. So the light group node is from a random starships. It's all about it's all about combining all the geometry and the textures to make the object really believable. There we go. Fortunately, right now I don't have any space HDRI. The closest I get is the studio lighting, but it's really sharp. It's really, really sharp. Let's use this one instead. For this one, alright. So I think this is right now. This is I like the result. I like the look of this one, so I'll probably go for this one right here. If you were to manually if you like to manually um UV at least the base mesh, you can try and the mark sharp here is from when we use the random vertex color sharp and then use the mark sharp toggle. So essentially what you're going to do is, let's see, clear sharp. What you can do to make it faster to UV this kind of mesh faster is that uh, before you detail it using plate insets or use any random operator, UV it first in the base mesh, and that UV layout will be inherited in the result of the randomization. Um, but you still have to repair some of the parts, but at least it's easier for you. But for this one, that's already finished, you can mark sharp. You can look for the, mark sharp. Mark sharp the sharp edges. F3, mark sharp. Oops. F3, get sharp. Okay. And then Control E. Should we just, yeah. Let's just mark sharp so you can easily select it afterwards. So select the mark sharp edge, Shift G, and you can easily select it using Shift G, sharpness. And then Control E, mark seam, and then U and unwrap. Some areas still needs repair, but with this, the idea of the seams, look at this. It's chaotic, right? But if you want to repair the part, let's look at the render. Let's say this one, and I want to find out where the heck is it in this layout. So you can just use L. Oops, L. There we go. Go to face mode, not go to face mode by pressing 3, and then hover over the faces, the mouse cursor, and press L. It will select those faces until it hits an edge that is marked. That is how can I call it? An edge that where the seam is marked. Okay, an edge where the seam is marked. An edge where an edge where yeah, the seam is marked. And in the UV, you can see that it showed you where it is. And then we can rotate this. There you go. So again, go to face mode, L, and it will show you where the face is, and you can orient it and look at the effect on the texture. Okay, so that's how easy it is. So there's a lot of techniques you can use when trying to UV the results of random flow. It's not that hard. Okay, I'm going back to the light map pack. Okay, there you go. So we made the base mesh, break the inner space and outer spaces, I mean. And then we made our shader and also the lights. And this is pretty much, so you render this in your scene. Then if you have skills with painting, you can overpaint it. And if you have really good skills with composition, of course, this can really look good after a post. You can actually render it much closer. Let's try and render it at this distance. Okay, that is still good. The uh, the geometry we did to break up the outer spaces is still visible. So if like this one here, so if those geometries are not visible, you can just delete it to save up on the resolution of the scene. Okay, so you can actually after this select everything, and you can join the mesh together. Extras, join objects to the cylinder. Now they are single mesh. You can still separate it in this form because each of the objects have been saved right here. Let's try and split this. Split from cylinder, and you can see that the objects have been separated. But we have messed up with the vertex data, but that's okay. Okay, so like that. And okay, probably save. Okay, saved right here, and then join to cylinder, and then you can press X limited dissolve to, if you want to make this lighter, press X limited dissolve, and yeah, activate. So from 19K faces or 38 triangles to 18,000 triangles. And then you can save it into a file and then bring it to your save this blend file, and then bring it to your asset folder, and then you can use it for your asset browser. You can just drag and drop it on the scene if you need this object right here again. Okay, outliner. Let's see if the limited dissolve messed up the yeah, it did. So yeah, probably avoid that if you're using light map UV. So there you have it, your simple space station using random flow. Okay. Probably in the next video, we're going to incorporate random animation a bit. And that's it for this video. I hope you learned something and um, stay for the next video. If you have any questions, use the comment section or the links in the description of the video. Thank you for watching and have a nice day.